how we do the inferential statistics. This is the question number 2. How we do the inferential statistics means answer is by applying the hypothesis testing. We are going to do hypothesis testing. How we do the inferential statistics means by applying the hypothesis testing. Question number 3. Now, what is hypothesis testing? Hypothesis testing means hypothesis testing means there is a statement a population parameter should be or should not be rejected. Okay, so we'll have a statement. There is a statement regarding the population parameter. There will be one statement. Should we have to accept or reject that statement? The statement is null hypothesis, or whether it is an alternate hypothesis, any statement, or that hypothesis. So in this, now the question is, next question, what is the difference between null hypothesis versus alternate hypothesis? What is the difference between null hypothesis versus alternate hypothesis? This is the next question. So before to this question, what is null hypothesis? What is alternate hypothesis? Instead of asking this question directly, they'll ask the difference between both of them. So in that, automatically null will be included, alternate also will be included. Instead of asking two different questions, directly if you ask the difference means it will be included. So null hypothesis means says that whatever the present situation is there, assumes that as the best situation. Whatever the present situation. For example, my students are understanding very well. That is my assumption. Whether you are understanding or not, I'm going to test you. For example, today morning, I have conducted the test for the morning 9 a.m. batch. This earlier you have seen the papers, right? This is the morning 9 a.m. test only. And suddenly I have kept surprise. I have not intimated them. I assume that last Saturday and Sunday, they have practiced at home. That is my assumption. I assume that they have done the practice and they have done with respect to the things, whatever was completed in the last week. Suddenly morning, after completing the topic, from 9 to 10:30, the topic time, 1.5 hours. After immediately 10:30, we have started the exam. At the same time, it is not mandatory. Some of the students will not plan for that. They'll already fix with other plans. They want to go outside. Something will be there. So simply I told that if you are interested, you write the exam. If you're not interested, you can leave. But every student has written the exam. And out of which you can see that the marks. Just now the mentor has given, right? One of the students has received 50 out of 50. And two students has got 43, 49, 48, 46. 50 out of 50, one more student, 49, 48, 46. Hey, what are these marks? Very good marks. At the same time, some students are there, 9, 8. 8 is the least. 8 is the least. Some students are there, out of 50 marks, some students has received 50, some students has received, out of 50. Sorry, first I have to tell that one, out of 50. Out of 50 also, few students has received suddenly. Surprise test. If you want doubt means tomorrow morning, you can come and you can ask whether I have conducted surprise or not. Okay, for these small things, I will not like. Okay, right? If you want, you can come and ask tomorrow. Suddenly, that is, as some of the students are saying voices. Guys, others, can you please confirm, is my voice is loud and clear? It is loud or not? It is clear, right? Done. So, just today morning, just when we have done this sudden test, surprise test, right? Not properly. Guys, if you are, it is not clear, can you please relog in once again? If it is not clear, can you please relog in? So sudden test, what are the sudden test I have kept? My null hypothesis says that they have practiced. Alternate hypothesis says that they have not practiced. Whether they have practiced or not practiced, I'm going to do the hypothesis testing. This is the data. Now, based on the data, I'm going to estimate. Means all the students has not participated, right? At least 1 or 2 students might be on leave. So all the students has not participated. Obviously, it is a sample data. So based on the sample data, whatever the marks I'm having with me, based on these marks, I'm going to conclude whether they are practicing every day or they are not going to practice every day. Right? So just based on the confirmations, based on that, we are going to add something, and if they do better every day better, automatically we'll add something and they'll get the more benefits, right? Whatever the course fees they have paid, than that they'll get more benefits only. For that, whatever the best we can do, we are delivering. Right? Now, null and alternate hypothesis. What is the difference between null and alternate hypothesis? Means null hypothesis is a assumption about the present situation. Whatever the present situation is there, status quo. Null means no difference will be there. Null clearly says that there is no difference. Whatever the present situation, generally one student means they have to practice every day. Those only are called as students. Students means not only listening to the class are called as students. Who will do the practice, who will understand the concepts every day, something they will learn, something. Those are called as students. So by default, null hypothesis means that, right? Alternate hypothesis. What is the alternate hypothesis, miss? The alternate hypothesis is nothing but just opposite to the null hypothesis. Whatever you have mentioned in the null hypothesis, alternate hypothesis. Your research hypothesis, alternate hypothesis also called as research hypothesis. What you want to implement newly when compared to the old one, what you want to implement newly, everything comes under null alternate only. Okay. For example, tomorrow you are going to say that, sir, instead of this one, this is better. Something you are going to try. Something you want to prove something is better than the existing one. Always that comes under alternate. Your research comes under alternate hypothesis, right? Next question. What is the difference between null and alternate hypothesis? How to formulate the null and alternate hypothesis. The null and alternate hypothesis. How to formulate the null and alternate hypothesis. This is the next interview question. How to formulate that? Based on this given question, by assuming that there is no difference. We are going to formulate the null hypothesis by assuming there is no difference. Okay. Alternate hypothesis says that there is difference. Next, what are the different types of tests available? What are the different tests available? Different hypothesis tests. Different hypothesis test. What are the different hypothesis tests available? Okay. We are having with respect to one parametric test and non-parametric tests. Question number 7. Difference between parametric and non-parametric tests. What is the difference between parametric and non-parametric tests? What is the difference between parametric and non-parametric tests? Parametric test means, what is the difference between parametric test versus non-parametric test? Parametric test means assuming the data is applying the hypothesis test on the normal distribution data is called as parametric test. Applying the hypothesis testing on the skewed data is called as non-parametric test. Right? Now, what are the different parametric tests are available? Different parametric tests. What are different parametric tests? Parametric tests. So before to this, first let us understand how to, you told that what is the difference between parametric test and non-parametric test is parametric test where we are applying the hypothesis testing on a normally distributed data, and non-parametric test means applying the hypothesis testing on a skewed data. Okay, fine. Now, how to identify whether given whatever the given data is there, given data is normal or skewed. How to identify whether the given data is normal or skewed means we are having multiple options in that. What are the different options means within that? Option number 1. First option is check the skewness value. Skewness value. If the skewness value lies between -1 to +1, it is normally distributed. If it is less than -1, it is left skewed. If it is greater than +1, it is right skewed. Option number 1. Option number 2. See the histogram. Okay, see the histogram. So from the histogram, check the tail, whether you are having right tail or left tail, by seeing the just observation based on the histogram. This is the second option. Third option, based on the box plot. If both the boxes are same and along with the whatever the whiskers are length is same, whisker length and box length, everything are same, it is said to be a normal distribution. And for the normal distribution, mean, median, mode will be the same. That is one more option. And next question, is there any hypothesis test? Is there any hypothesis test to check whether data is normal? To check whether data is normal means, yes, there is one test also is available. That test name is called as Shapiro test. Today I'm going to show you this. There is test called as Shapiro test. Using the Shapiro test also, we can check whether the data is normal. Answer will be the same. Whether you check in the histogram, whether you check in the box plot, whether you check in the skewness value, whether you check in the Shapiro test, answer will be the same. There will be no difference in the answer. Answer is going to be the same. For Shapiro test, fix every time. Null hypothesis says that null hypothesis is data is normal. Data is normal. Alternate hypothesis says fix every time, fix. It is not going to change. Data is not normal. Okay, if the data is not normal, you are going to take the action. What is the action means? You are going to convert. Okay, if the data is normal means you are not going to take action. No action is required for that. Right? So Shapiro test. So based on the p-value, either we'll accept or reject the null hypothesis. For Shapiro test, we'll see the p-value, and based on the p-value of the Shapiro test, we are going to confirm. Example, let us see now itself immediately. Okay, instead of after some time, let us do it now. Now we are having, in the last class, we have done here the fabric data. Okay, for the fabric data, we have done the skewness. We have checked the skewness. Okay, so this is not the original fabric data. For example, let us go with the bold data. Okay, bold data, bold diameter data set, which we have already completed. One sample t-test data set, whatever we have done. For this data set, we already checked the skewness, and the skewness is between -1 to +1. So we are going to accept this one as a normal distribution, and we have continued with the parametric test in the last class. Now let us see the same thing by using the Shapiro test. Second option, you can select this one or Shapiro test. Choice is yours. Out of which this one is the easiest one. Whatever we have discussed, that is the easiest one. But in the interview, they may ask you this one. So that is the reason we are discussing. So stats.Shapiro, test name is called as Shapiro test. And within that, you have to give the data column name. Whatever the column is there, the column you have to provide as the input. Now, once you provide the input, you are going to get the p-value. Since the p-value is less than alpha, p low, null go, p high, null fly. So based on the p-value, we are going to accept or we are going to reject the null hypothesis. Is that clear? So just if you take with respect to whatever the data set, you can select whatever the data set. For that data set, every time the null hypothesis says that data is normal, alternate hypothesis says that data is not normal. Right? That is one more, Shapiro test. Next, we are having, okay, with this, we are going to conclude whether the data is normal or not. Like this, in the different ways, we are going to conclude. Next question is, what are the different parametric tests are available? What are the different parametric tests? First one, what are the different parametric tests means? First one is one sample test. First one is one sample test. Within the one sample test, again, we are having with respect to one sample Z test. And the second one we are having is one sample T test. These are the two T test. Right? So one sample G test and one sample T test. Now, what next one? What is the second type of test we are having is two sample test. Two sample test. Okay. Again, within this, we are having option within this. Again, option A with equal variance. With equal variance. 2 without equal variance. With unequal variance. This is the second one. Okay. So we are having two tests. One is called as equal variance test and the second one is called as unequal variance test. And along with that, we are having with respect to third type of test is called as ANOVA test. Right? And the fourth one, we are having the fourth one is called as one proportion test. One proportion test. And the next one we are having is two proportion test. Two proportion test. And last one we are having is chi-square test. Okay, these are the different types of tests which we are having, right? So out of these all the tests, now next question, question number 11. What is the difference between, what is the difference? What is the difference between, what is the difference between z-test, one sample, z-test versus one sample t-test? What is the difference between both of them? This is the question. And out of all these questions, this is the most important question. Till now, whatever we have discussed within that, this is the most important. So z-test, and what is the difference between the z-test versus t-test? Z-test, where the z-test is having, okay, z-test works on the z distribution. Okay, it works on the z distribution, whereas t-test works on the t distribution. Now, what is the difference between z distribution, t distribution? Z distribution, where the population standard deviation is known. Whenever the population standard deviation is known, we are going to apply the z-test. Whenever the population standard deviation is unknown, in that case, we are going to apply the t-test. Okay, now that is the major difference between both of them. And the probability of the z-test, whatever the probability is there, that will be checked in the z table, and probability in the t-test will be checked in the t table. This will be worked on the population data. Z-test works on the population data. T-test works on the sample data, because the t-test formula is x bar minus mu divided by s by square root of n. Yes, sir. We are having s, sample standard deviation, right? So that is the difference between both of them. Means population standard deviation is known, and if you work on the population standard deviation, then we have to work on the one sample z-test. If the population standard deviation is unknown, then in that case, we have to work on the sample standard deviation. In that case, we are going to select the one sample t-test, right? That is the difference out of these two. Now, for example, now if your sample size is greater than 30, if your sample size is greater than 30, there is no difference between t-test and z-test. Because after the 30, whatever the probability values in the z table and in the t table, everything will be the same. There will be no difference. Okay, below the 30 only, lot of difference will be there. More than 30, there will be no difference. That is the reason. That is the reason why minimum sample size. What is the minimum sample size required for doing the, for applying hypothesis testing? For applying hypothesis testing, what is the minimum sample size required? Means the answer is 30. What is the minimum sample size required for applying hypothesis testing? Means the answer is 30. Why answer is 30? The reason. What is the, why the answer is 30? Means after 30, what are the probability of z-test and the probability of t-test will be the almost same. Almost same, not exactly, almost. Means up to 1 decimal. Up to 1 decimal only. Sir, I want up to 3 decimals. Means perfectly it should be close. Means sample size is more than 1000. Means you can't find even minute difference also. 0.000001 difference also you can't observe if the sample data is more than 1000. If the sample data is more than 1000, there is no difference between the z-test and t-test. In the real life, everyone will apply on the directly on the t-test only. None of them will open the z-test also, because population standard deviation in the 99% of the cases we don't know. Now, most important question. This is my favorite question. In real life, whether you know population standard deviation, is that practically possible? In real life, whether you know the population standard deviation. Population standard deviation, you know, means some population data should be there, right? Population data is there, means then why you to do this, all these things? Hypothesis testing only, no need to do. If population data you are having and you are able to do that one, means what is the use of all these things? So in the real life, whether population standard deviation will be available? First question, will be available? The answer will be obviously no only. The answer is obviously no. It is not possible. The answer is obviously no, because to do that one, first we have to collect the data. That is, answer is no. Now, how we are going to handle then one sample Z test? Then what is the use of discussion of one sample Z test? You don't know that one. Nah? Without knowing that one, you can't do. Then what we have to do is simple. That is the reason for this, how to overcome. How to overcome this one is we have to select. Answer is no. In what is this today? Audio issues. In order to overcome this issue, this problem. Issue means here problem. In order to overcome this problem, what is the problem? Standard deviation is unknown. That is the problem. In order to overcome the problem, what we have to do? We have to color the minimum sample size of 30. We have to collect minimum sample size of 30. That is the solution for that. If possible, 1000. If possible, 1000. Again, they will ask question. Why 1000? That is okay. You only told that 30 means there will be no difference. Again, why you are saying 1000 means more accurate results you'll get with respect to if it is more than 1000. Okay, more accurate results you are going to get. Up to 1 decimal is okay. 0.6 and 0.64 both are same for you means okay. 0.64 and 0.63 you also difference for you. Exactly you want up to 2 decimals, you want perfectly answer, you want up to 2 decimals means better to select the 1000. Then you can get up to 3 to 4 decimals also same answer. There will be no difference between that Z test and T test. That is the difference. Is that clear? Next. So in the real life, we'll get the minimum sample. We'll try to collect the minimum sample. If the sample size is less than 30 means will not even work. Generally will not work. We'll say that please try to collect the more data to the data engineering team. If they're not able to collect means we'll try to collect. But with less than 30 will never work in the entire statistical analysis or with respect to the data science or machine learning. Any project will not work. Minimum sample size should be 30. Okay, n. Minimum sample size should be of n. N is greater than 30, greater than or equal to. Equal to is also okay. N greater than or equal to. Minimum sample of greater than or equal to 30. Up to that, minimum 30. 20 records only is there. Better to not to apply. If you apply miss, standard deviation should be known. If it is less than 30 miss, 100% population standard deviation should be known, and you have to select Z test and T test separately. If more than 30 is there, whether you apply Z test also no problem, whether you apply T test also no problem. Apply as per your choice, whichever you want. If it is sample size is more than 30, apply whatever you want. There will be no difference. Okay. Next question. What is the next question, miss? Now, what is the difference? What is the difference between? What is difference between one left tail versus right tail versus two tail? What is the difference between these two? What is the difference between left tail, right tail, and two tail? If null hypothesis rejected on the left side, then it is called as left tail test. If the null hypothesis getting rejected on the right side, then it is called as right tail test. If the null hypothesis get rejected on the both sides, then it is called as two tail test. Which side the rejection area of null hypothesis is there, that side is the test. Rejection area, whatever the rejection area is there, on which side of the test we are having. Okay, if you are having the rejection on the left side, then it is called as left tail test. Rejection on the right side, right tail test. Rejection on both sides, two tail test. Which rejection? Rejection of null hypothesis. Null hypothesis rejection, not the alternate hypothesis. Null hypothesis rejection on which side we are having, that is considered as the test. Okay, with respect to left tail, right tail, and two tail. Next question. What is meant by level of significance? What is meant by level of significance? Next question is, what is meant by level of significance? Level of significance means at what error we are going to reject the null hypothesis. With what error rate we are rejecting the null hypothesis is called as level of significance. The error rate at which the null hypothesis will be rejected. Right? So if they ask a level of significance of 0.05 means with 5% error rate, you have to reject the null hypothesis by considering 5%. You are not going to reject the null hypothesis exactly 100%. You are not able to do this. At least I want the accuracy of 95%. That is the requirement. Right? Now, is that clear, guys? Now, what is meant by level of significance? Now, automatically, what is meant by confidence and confidence? Opposite to this is confidence. What is meant by confidence? The level at which you are accepting the null hypothesis. The error rate with which what you are rejecting the null hypothesis is called as level of significance. With what level you are accepting the null hypothesis is called as confidence. Means, for example, if you take like this is the 5%. This 5% is the rejection area, left tail test. Let us take the left tail test. This is the rejection area. Level of significance means error level at which I am rejecting the null hypothesis. This is all called as rejecting the null hypothesis area. Remaining 95% area is there. This is everything is accept the null hypothesis area. Remaining 95% area is accept the null hypothesis area. 5% of the area is to reject the null hypothesis area. Right? So confidence means this area is considered as confidence. This area is considered as level of significance. This is considered as level of significance. That is the reason confidence is equal to 1 minus alpha. One total area is 1, right? Level of significance alpha. This is alpha. Confidence is 1 minus alpha. Total area is 1 minus alpha. That is the reason. Is that clear? So this area is called as confidence area. This region is called as error area. Okay. Now, that is with respect to what is meant by confidence. Next. Okay. Next question. Question number 17. All these things we have completed. Nothing. Okay. All these things we have already completed. Now, what is next question? Coming to the next question. Difference between one sample z-test and this one. Now, next question is explain the process. Explain the process of hypothesis testing. How we are going to do. Explain the process of hypothesis testing. Explain the process of hypothesis testing. First, we are going to formulate null and alternate hypothesis based on the statement, based on the project. Okay, we are going to formulate the null and alternate hypothesis. And we are going to identify the level of significance for which we have to do this project. At what error rate we have to conclude this project. Right? That is level of significance. Third one is we are going to color the data and check whether it is a normal or skewed. If it is a normal miss, we are going to apply the parametric. If it is a skewed miss, first we'll convert, then we'll apply the parametric. Okay. Next, after that, next, what is the next step? We are going to select the test, and from the test, we are going to calculate the p-value. And based on the p-value, we are going to accept or reject the null hypothesis. Right? So this is called as process of null hypothesis testing. Now in this process, whatever you have told in that third point, that is color the data and check for normal distribution. If the data is normal, means proceed with the parametric. Otherwise, convert to normal and proceed, you told. Why you have to convert? You can apply non-parametric now. Already you told in the earlier what is the difference between parametric and non-parametric, means you told that non-parametric tests are applied on the skew distribution. Directly you can apply the non-parametric only, right? Why you are applying all these things? Sir, as a data scientist, we are going to deal with the normal distribution data in every case. So instead of dealing on the skew data, it is better to convert to normal distribution and apply the parametric test. Right? As a data scientist, we'll always work on the normal distributed data. We assume the data to be normal. Not only this hypothesis testing, wherever it is, we assume the data is normal. So based on that only, we'll apply everything. Whatever the things we are going to do, that entire data science project, the CRISP-DM methodology, whatever we have discussed in the demo class first today, CRISP-DM methodology, the entire data science project life cycle is there. The entire life cycle we are going to do by assuming the data is normal. So that is the reason I'm going to convert the data to normal and I will apply the parametric test instead of applying the non-parametric test. Since both of them will result to the same answer. So my choice will go with the conversion of skew data to normal and apply the parametric test. Is that clear? In that way, you have to answer. If they'll ask you why you have to do, you can clearly say that as a data scientist, you add the word as a data scientist. You are not a statistician. If you are a statistician, you can't use that word. Because you are a statistician role and you are applying as something like that, then automatically you have to learn the non-parametric tests also. One sample sign test, we are having with respect to so many, almost 4 to 5 different are there. And all these things are with respect to non-parametric tests, right? Now, next question. Okay, that is 18. Now, how to select which test to be done? How to select the test? How to select the test? How to select the test for the given problem? How to select the test for the given problem? Right? So first we are going to check the test is done on the continuous variable or a discrete variable. If the test is done on the continuous variable, then I'm going to select either one sample or two sample or an hour test. If the test is going to be done on the discrete variable, then I'm going to work on the 1 proportion, 2 proportion, and chi-square test. Next question. How do you know that you are working on the continuous variable or a discrete variable? How do you know that one? How to identify whether you are working on a continuous variable or discrete variable? How you know? Means statement will be there, right? Mean means average. Average value is greater than 100 ml. Average is greater than 100 ml. Mu is greater than or equal to 100 ml is the null hypothesis. 100 ml means what? Continuous variable or discrete variable? Sales are there, continuous or discrete? Marks are there, continuous or discrete? That we have to apply the logic. So for what we are doing the hypothesis testing, that we are going to select. Guys, online students, sorry, in between you are getting low sound. Sorry, today there is some kind of audio problem. Okay, maybe some technical. I will check with the team. So in between, again, it is getting connected. Again, it is getting disconnected. I don't know what is the reason. Right? Yeah, sometimes voice is high, sometimes voice is low. Yes, here there is some kind of technical problem. Right? Now, next one. How to select the test miss based on the given problem. So given problem, first you have to formulate. First write the null hypothesis. By writing the null hypothesis itself, we can say whether it is a continuous variable you are applying or alternate hypothesis. For example, you say that, sir, this is going to increase the sales. Sales means automatically the word of sales means continuous variable only. So this is going to increase the marks, continuous variable only. This is going to increase this one. Based on that, what is the variable? Based on that, we are going to select the test. If it is continuous variable means continuous, discrete means discrete. So here, how to select the test for a given problem is the test will be selected based on the what is the parameter you are considering in the null and alternate hypothesis. Can you apply the mean for a discrete variable? No. Can you apply with respect to mean for a discrete variable? No. Mean or can you apply the variance for a discrete variable? No. Can you apply standard deviation for a discrete variable? No. Whether the both of them variances are equal or not, I'm checking both the variances are equal or not. Miss variances for what variable we are going to apply? Continuous variable only. How you can apply the variance concept on a discrete variable? Right? Simple. Your null hypothesis statement says that whether it is you are working on a continuous variable or a discrete variable. Right? How to select the test miss based on the null hypothesis? Answer is based on the null hypothesis. Whatever the null hypothesis statement is there, based on that, we are going to select the test. For continuous variables, continuous tests, and for discrete variable, discrete tests. Right? Next one. So we have seen what is the difference between one sample Z test and one sample T test, and we have seen the process, everything. Now, next question. What is meant by two sample test? What is two sample test? What is two sample test? You are checking between two continuous variables, whether they are both are same or different. Okay. Comparison between two population variables, whether both of them are same or not. means there is a difference or there is no difference. Okay, applying the hypothesis test on a two continuous variables to check whether there is a difference or not is called as two sample test. Next, what is next question? What is the difference? Just call them, any one of the person, please. Why we are discussing this one means important interview questions. All the interview questions for every topic at the end will do like this. And based on that, I'm going to conduct every week one test. And the test will be for you tomorrow on inferential statistics. Complete inferential statistics, the test is tomorrow, as I've told you already on the Friday class itself. And you told that we'll take on Tuesday itself. So tomorrow, you are going to take the test. Whoever the students are interested, you can come down by 5 o'clock. 5 to 6 will be the test, and 6 to normally it is going to be the class. Between 5 to 6. Right? Whoever are interested. If you don't come, miss, that is your choice. Just I will analyze. I will analyze which student is coming, which student is not coming. That is analysis I will do. That's it. Nothing will be difference. Okay. But surely I will analyze. Every student I will analyze. If you are very sincere only, you come. After coming here, if you are interested to see others papers, miss, don't come. No need to come, no need to cheat. If you cheat and if you get 2 marks, 1 mark extra also, there is no use. If you don't come also, for me, no problem. Absolutely no problem. This one is not going to impact any on the placement distance or something. If you attend only, I will give the placement distance. If you don't come, miss, I will not give. No new rules I'm going to create. Additional benefit I'm giving. If you want, miss, utilize. If you don't want, miss, don't utilize. That is your choice. Whatever we have not discussed in the demo class, additional benefit. I told that. I didn't told anything like interview. I am going to conduct the mock test every week, and I have not given any promise like that, right? This is additional. Okay, to check yourself every time you are preparing or not, to check yourself. Pavan ప్రతిసారి డిస్కనెక్ట్ అవుతుంది, కనెక్ట్ అవుతుంది, సౌండ్ చాలా ప్రాబ్లం అవుతుంది. ఒకసారి చూడవా? Online students, now it is clear. When compared to earlier, can you please come for me? It is clear now. Right. Done, guys. So next, what is the difference between two sample test versus ANOVA test? What is the difference between two sample test versus ANOVA test? First, let us see what is meant by ANOVA. ANOVA means analysis. AN stands for analysis. O stands for of. VA stands for variance. It is nothing but analysis of variance. Whether both of them are having equal variance or not. Sir, same test we have done in two sample also. Two sample also same, ANOVA test also same. Whether both of them checks with respect to analysis of variance. Whether it is a two sample also, check whether both the samples are having same variance or not. Then what is the difference between both of them? Two sample test. What is the difference between two sample test versus ANOVA? What is the difference? Two sample test means where it is going to check between two variables. Check between two continuous variables only. It checks between two continuous variables only, whether their variances are equal or not. Whether variances are equal or not. That is two sample test. Okay. Coming to the ANOVA now. So in the ANOVA test, okay, check between two continuous variables only here. It is going to check more than two continuous variables. That is the difference. It is going to apply only for two variables, but ANOVA test will be applied equal to or greater than two variables. Sir, equal to or more than two continuous variables. It is going to check whether variances are equal or not. Whether variances are equal or not. For example, sir, let us take like this, sir. I am having exactly two samples. Two samples means two futures. Okay, I'm having exactly two. Now, should I apply two sample test or another test? Whatever you feel interest, apply. Answer will not change. Answer is same. There will be no minute difference also. Both are same. Exactly two are there means if you apply two sample test also, another test also, no problem. But more than two are there means you can't apply the two sample test. Now, sir, let us see that one. In the last class, if you remember, where we have stopped is credit card promotion, where we are having with respect to standard Christmas promotion versus full interest rate waiver. And we have checked for normalities and we have applied the two sample test. And based on the two sample test, we have got the p-value. P-value is 0.01. The p-value, whatever we have got is 0.01. Since p-value is 0.01, which is less than 0.05, p is less than alpha. Since p is less than alpha, we have rejected the null hypothesis, right? This is the one which we have done in the last class by applying the two sample test. Now, if you do instead of two sample test, if you are applying the ANOVA test, okay, the same example, ANOVA test, same to same. Whatever you are having here, two futures, that is interest rate waiver, standard promotion. Okay, these are the two columns. Column number one, that is future number one. This is future number two. Two futures, you are analyzing whether their variances are equal or not by assuming the equal variance is equal to true, right? So this is the t test underscore ind. T test underscore ind means nothing but two sample test. Now the same data, I'm not going to change the data set. Just I'm going to apply the ANOVA test. For ANOVA test, what is the function means? The function is f underscore one way is the function name. ANOVA test is also called as f test. ANOVA test is also called as f test, right? ANOVA test is also called as f test. Both are same. ANOVA test and f test both are same. Now here one way ANOVA, f underscore ANOVA, right? One way. Now if I apply this one, okay, if I apply this one and if I'm clicking on this, now same answer I'm going to get. Again, p-value is less than alpha. I'm going to accept or I'm going to reject the null hypothesis. Based on the alpha p-value, p is less than alpha, reject the null hypothesis. Whether you apply the ANOVA test also, the answer is same. Whether you apply the one-way ANOVA also, answer is same. There will be no difference. So in the last class, I have shown you if you are having greater than symbol, then you have to go with the greater than. If you are having less than symbol means you have to go with the smaller. If you are having two-sided means you have to write here two-sided. Means two-sided means two-side. Alternate is equal to two-side. If you don't write also, automatically it will select. No need to write also. Answer both the p values are same. In the ANOVA test and t test, answers are same. Is there any difference in the p value? Not even minute difference also you can observe. If the data is same, this one and this one, if the data is same, by default, automatically it will take the equal variance is equal to true only. If you don't write even this one also, it will take automatically that one only. By default, it will take the true only. So if you go with the two sample test or if you go with the ANOVA test, there is no difference. Okay. But if you are having more than two samples, if you give here the third sample name, whatever the third column, if you add third column, it is going to throw the error. Because this function was created by considering only two arguments. If you click on the shift tab, you can see it is created only using the two columns, A and B. Only two. You can't give more than two. Remaining all of them are default parameters. Okay. Compulsory arguments are two. Two parameters we have to give. Whereas if you observe the ANOVA test, you can give with respect to 2 to more than 2 also. No limit on that. So that is the reason generally for two samples, we'll go with the ANOVA only. Generally, if you are having two miss, we'll go blindly with ANOVA more than 2 or anything. So generally, everyone will learn only two things. One sample. Generally, everyone will learn in the real life only one with respect to one sample t test. Second one is ANOVA test. Only they will learn only two. They will not even learn the Z test. They will not learn the two sample T test, for equal variance, unequal variance, nothing they will learn. Directly, they will learn only two things. One is one sample T test, one is ANOVA test. Only these two they will learn. Remaining everything are not required for them. But in the interview, they'll ask all these questions. Whatever we are discussing, everything in the interview, they'll ask. But in that class, the trainers will not explain all these things for data science particularly. Okay. Now, here one sample T test. For one sample, if you're going with one sample miss, go with the one sample T test. If you're going with more than one sample miss, go with the ANOVA. Simple, no different. Okay. Now, okay, sir, I'm going with ANOVA. What is meant by ANOVA? ANOVA means analysis of the variance. Okay, fine. Now let us take the total three samples are there. X1, X2, X3. Three are there. Okay, sir, three. Now, what is the null hypothesis says that? Null hypothesis says that no difference between the variances of three of them. No difference in variance of the three variables. Of three variables, there is no difference. Alternate hypothesis says that there is difference in the variance. Every time fixed. It is not going to change. Every time it is fixed. Okay, three variables means 3, 4 means 4, 5 means 5, whatever it is. No difference in the variance. Alternate hypothesis says that there is a variance. Now, assume this is I'm having the morning 7:30 a.m. batch. Okay, this is called as 9 a.m. batch. This is called as 6 p.m. batch. My null hypothesis says that there is no difference between three batches. Whatever my three batches I'm having, there is no difference. This is my null hypothesis. Alternate hypothesis says that there is a difference. Now I got the p-value less than 0.05. Assume I have applied the ANOVA test and I have got this one. Okay. Now what is the meaning of this one? P low, null go. Null go means reject. Automatically there is a difference. Answer is difference. Means they are not equal. Now three of them are not equal. Out of that, two may equal, right? 2 may equal and maybe 7 and 9 may be equal. 6 p.m. is something different. Maybe 6 and 9 might be equal and 7:30 might be different. Might be. So then when you are having the multiple like X4, X5 like this, when you are having more number of columns, out of all the columns, every column may not be equal. In that case, what we are going to do? First, we'll try with overall. After that, each two variables we are going to combine. Every two variables will apply, and for two variables we'll apply the two sample test separately, and we'll check whether they are equal or not. Okay, overall these three are not equal, but maybe right. So maybe these two equal, this one and this one, these two equal, and this is not equal, right? So this is not equal. Then automatically, if this is not equal, but I will get the final answer as everything are not equal. So separately, these two I'm going to consider separately. This one I'm going to consider separately. So in that case, two sample t-test will be applicable in the real life. That is the reason why in the interview also they'll ask you the question with respect to two sample test. The question is, what is meant by ANOVA test? First question. First they'll ask this question. What is ANOVA test? After asking the ANOVA test, automatically we will answer that one. What is ANOVA test? Explain ANOVA. Explain ANOVA test. First they'll ask this question. Obviously, students will answer. Means whatever the persons are there in the interview, they'll answer. Sir, analyzing two or more than two variables, whether their variances are equal or not. Analyzing two or more variables, more continuous variables. Analyzing two or more continuous variables to check whether their variances are equal or not. Whether their variances are equal. To check whether their variances are equal or not. This is called as ANOVA test generally. Now immediately they'll ask. First they'll ask what is ANOVA test first. Okay. 99.99% of the people will answer this one. Okay. Most of the people will answer this one up to this question. Immediately after this one, they will ask the next question. Okay. Assume that there are total 4 variables. Out of 4 variables, null hypothesis says that all of them are same. Alternate hypothesis says that everything are different. Okay. Now, within that 4 variables, maybe 2 variables might be same. Out of 4, any 2 might be same. How you are going to check them? 99.99% of the students will see at my face only, but they'll not answer. They'll answer what is ANOVA. Explain ANOVA means they'll answer. But if I ask this question, they'll see at my face. Because they know either accept or reject null hypothesis only. After rejecting the null hypothesis, what we have to do, that they don't know. If the null hypothesis accepted means variances are equal, happy, no difference, no problem. If the variances are not equal, okay, no action is required means no problem. Action is required. What action you have to take? Action required. Okay, what action? Action means what? Variances are not equal. Okay, variances are not equal means what you have to do? Check which two are equal. Now, example, let us take with an example. Here, this one, contract renewal. There is a data set called as contract renewal, right? Just can you tell me what is the null and alternate hypothesis for this data? Variance in the transaction time is same. Variance or average, whatever the mean time. If they are working on the mean means means are same. No difference in the means, mean transaction time. If they are working on the variance means the variance of the transaction time is same, right? Now, this is the question. Now, how many suppliers you are having? Total 3 different suppliers. Supplier 1, supplier 2, supplier 3. And their time, for each of them, time is there. How much time they have completed their work. What are the work you have assigned? Different works you will assign, right? What is the time you have completed? Now, okay. Now, let us assume, instead of this, I will tell still more easy example for you. Okay. Now, in a company, in your, okay, in a company, members, team is there. In the team, members are there. And these people are working in the company. Okay. There is a team leader. For the team, there is a team leader. Assume that there are total 4 members are working in the team. Person 1, person 2, person 3, person 4. 4 persons are working in the team. Team leader is there. Now, it is almost with respect to the entire team, entire project was started on the same day. And every member is working on the same day. Everyone has started. Assume that everyone has started their work on the same day. Now, after 1 year, they have to give the bonus. The project was completed. Now they have to give the bonus. Now the bonus, whether are you going to give for every person same bonus? All the persons in the team are same or not? That is the question. Null hypothesis says that everyone are same, and for everyone you have to give the equal bonus. Whatever the bonus is there, 10% or 15% or 20%, whatever it is, you have to give for each and every person in the team same, in a same way. That is null hypothesis. Null hypothesis says that there is no difference. Alternate hypothesis says that there is a difference. Now, day 1, for this project, you have completed this entire project, assume in the total 4 months. 4 months means 120 days. Okay, on the day 1, whatever the task I have assigned, team leader will assign some task for every person, right? So they have assigned the task. And this task, the person 1 has completed in a certain time. For example, he has completed that one in the 6.5 hours. And he has shared the report. Second person has completed his task in 7 hours 20 minutes and he has uploaded the report. Third person 8 hours 45 minutes and he has uploaded the report. On the day 1, first day, this person has completed in 4 hours only. Just in 4 hours, right? Now, next on day 2, again different task, time. On day 3, again time. Day 4, again how much time they have completed, in what time they have completed. Whether they have completed correctly means it will be considered. Wrongly means delete also. That record will be deleted also. It will not be considered also. Right? So like this, we are having total 120 records are there. 120 days means 120 records will be there. Now these 120 records, they are going to analyze. And after the analysis, they are going to get a confirmation. If every one of them are same means for everyone equal bonus. Out of these two persons are doing very fastly. Sorry, not these two. This one, these both are doing the work on very fastly means for them, they'll give some additional bonus. For remaining 2, for you, your performance is not up to the mark. So in this particular year, we are not going to release any kind of bonus for you. You'll get a mail like that. Simple. Okay. Everything will be recorded. in the company. This is real life example. Once you join in the company also, whatever the task they have assigned, comparison, they're comparing because you are in a competitive world. You are in a competitive world where there is a comparison. Why they want to compare means you are in a competitive world. If you're not doing the work means immediately you will be replaced with another person. Right? Sir, actually there is a piece of work. One work is there. The work cost is 2 lakhs. Generally, the work is 2 lakhs. You are ready. Generally, you have to do that work for 2 lakhs. If you don't do miss, another person is ready for doing that work. You are in a competitive world where another person will do. No, there is no other person. You only can do. Then automatically instead of 2 lakhs, if you ask 4 lakhs also, they'll pay. Demand and supply. There is no other person means they have to accept whatever the conditions you say. There is no other option for them. But if they can replace you, then you have to control yourself and you have to accept whatever the things they are doing. And you have to work accordingly. Is that clear? This is one of the real life where the time of increment or with respect to the bonus or by the end of the project time, which the person has to be promoted, everything will be done the analysis. In the companies also will do this analysis. All the 4 people will not be promoted, right? Though the 4 persons after 5 years, they'll have the equal 5 years of experience. After 5 years of experience, they have to get promoted, assume. All the 4 of them will be promoted. No, 1 person only. From that, one of the person will again leads to the project manager. After that, finally, 1 person will become the CEO. All the persons who are having a good amount of experience and good amount of knowledge, everyone will become the CEO. No, right? Only 1 person. Which person? Check the analysis of variance, whether everyone are same or not. If everyone are same is, then we can't do anything. So here also the same. Here, the CMO wants to renew all the contracts if the performance of the suppliers are similar. If null hypothesis says that everyone are similar, automatically has to renew all the 3. If the alternate hypothesis says that they are not, the supplier's time is not the same. For example, supplier 1, supplier 2, supplier 3. You are going to take 3 and you are going to apply the ANOVA test, F_1 way. And you are going to give the 3 variables, variable 1, variable 2, variable 3. And you are going to get some p-value. If you get the p-value greater than 0.05, some 0.07, you have got value like this. All the variances are equal and you'll ask the CMO to renew their contracts, all the 3 contracts. For example, if you got the p-value less than 0.05, okay, if you have got less than 0.05, next you are going to check whether S1 and S2 are same, S2 and S3 are same, or S1 and S3 are same. You are going to check. If S1 and S2 are same means these 2 you are going to renew. S3 you are going to ignore. Which 2 are same? Those 2 you are going to renew. If everything are not same, out of which of them is the least having, that one you are going to renew. Only 1 person you are going to renew. Minimum 1 is guarantee. Because question, 1 of them we have to renew. Right? That is the question. Is that clear? So what is the difference between ANOVA test versus 2 sample test? Now for this data, let me check whether I'm having the data set or not. Yes, contract renewal data set is available. So just DF is equal to PD dot read. Read underscore Excel. This is Excel file or CSV file? Excel file. Read underscore Excel, and within that contract renewal dot Excel XX, and DF dot head, whether I have loaded a correct data set or not. Yes, I have loaded a correct data set where I'm having the supplier A, supplier B, supplier C. Okay, now what is the first step? Is formulate the null and alternate hypothesis. There is no difference between, everything are same. Second step is alpha is equal to 0.05. In the given question, nothing alpha is there also, fixed value of 0.05. Third question, check the normality. So first I'll check the normality. First DF of supplier A. Supplier A. First I'm going to check the skewness of the first supplier. I got the -1 to +1. So it is a normally distributed data. For supplier A, it is a normally distributed data. copy. Second one, supplier B. Again, it is a normally distributed data. Supplier C. Go with the supplier C. 3 of them should be. Any one of them is not normal also, you have to convert. Supplier C. Yes, this is also normally distributed. 3 of them are normally distributed. Okay, first one, second one, and third one. Now, what we are going to do? Now, we are going to apply the ANOVA test. How to apply the ANOVA test? Stats dot f underscore one way. Okay, and where you have to give the 3 values. The first one, second one, and third one. 3 of them you have to give. That is supplier A, supplier B, and supplier 3, C. 3 suppliers you are going to give as the input, and you are going to get the output as p value. Since the p value is greater than alpha, p high, null fly, miss all of them, you are going to renew. You are going to ask the CMO to renew all the contracts of all the suppliers. Like this, we are going to conclude. Is that clear? Now, here we have done the skew, checking the normality by using the skewness. Let us try with the Shapiro. Same question, we'll try with the Shapiro. Stats dot Shapiro. Okay, and give the input as one of the column, whichever the column you are interested. And you can see the p value. P is greater than alpha. P high, null phi. For Shapiro test, null is always data is normal. Fix, every time fix. It is not going to change. Shapiro test, null and alternate hypothesis, always fixed. No difference in that. Okay, only the null and alternate hypothesis difference is for the problem statement it changes, not for the test. Test always null and alternate hypothesis will be fixed. For Shapiro test every time. Is that clear? In the similar way, if you check with the supplier B also, the answer will be the same. P value is greater than 0.05. So it is a normally distributed data. If you try with the supplier C also, P value is greater than 0.05. It is normally distributed. Whether you apply the Shapiro test, whether you apply skewness also, answer is same. And how to check using the box plot and using the histogram, that I will show you in the Matplotlib. Because the plotting techniques you will understand in the tomorrow's class. Right? Tomorrow we are going to start the Matplotlib and Seaborn plotting. All right, right? Next, once this is completed, next move on to the discrete variable. So here there is a football where, sir, we are going to do the check the acceptability of the new football coach. Okay, so it was decided that if the support rate for the coach of entire population is less than 25%, the coach will be fired. For the entire population, not for the sample. For the entire population, if the support is less than 25%, they are going to fire. 2,000 people participated. 2,000 people are sample, not the population data. 2,000 people are participated. Now participated, out of which 496 people are supporting. 496 out of 2,000 are supporting the coach. Conduct a test if the new coach should be fired with 95% confidence. Now let us assume this is the population data. 2,000 of them are population. Entire population is only 2,000, out of which 496 people are supporting the coach. 496 of 2,000, which is equal to 0.249 something will be there, which is less than 25. Simply remove the coach. In one shot, we'll complete. No need to do any hypothesis test. But here it is not caps lock n. This is small n. This is small n, not the caps lock n. Since it is a small n, we have to do the hypothesis test. For population data, you don't need to do anything. Just by saying itself, you can conclude. If less than 25% is there, remove that. So directly remove. Question is very simple now. But this is not for population data, right? We got for 2,000 out 496 out of 2,000 is for sample. So for sample data, we have to apply means. So now, what is the process of hypothesis test involved for the discrete variable? Means what is the process? Means first step, formulate the null and alternate hypothesis for discrete variable. First step is common, no difference. Second step, level of significance, no difference. Third step, load the data. After load the data, check for normality, it will not be there. After that, check for normality will not be there, because normality concept is not applied on the discrete variable. Normality concept is applied only on the continuous variable. Histogram is applied only on the continuous variable. For discrete variable, there is no histogram, there is no normality, there is no skewness, there is no variance, nothing is there. There is no Shapiro test. Check for normality is concept only, not there for this. For discrete variable. For discrete variable, just load the data. No need to check. No need to check for normality. No need to check for normality. Why? Because it is not applicable. We can't apply. There is no concept to check for normality on the discrete variable. We can't apply also. We can't even apply. We can't even apply. Okay, there is no option only. Okay, concept only, wrong concept. If someone says that normality of a concept only, wrong concept. Because each one, whatever the number of males and number of females you are having, each category is a different category. There is no comparison. Males, females, there is no comparison. But if you take this continuous variable 0 to 10 marks, 10 to 20, this one variable, both are same marks, they are marks. Here there is no comparison only. How you can compare male and female? In this class, male students are more and female students are less, means males are greater. No. How you compare like that? In this class, 5 students are having 0 to 10 and 10 to 20, 20 students are there, means yes, these 10 students are great, obviously. These 20 students are great. Comparison is there. They are better, good students. Here, how you can compare between both of them? How greater than and less than symbol you can apply here? Here you can apply the greater than symbol, less than symbol, all these things. We can't apply that concept of here. Greater than symbol, less than symbol. That concept only we can't apply. Right? Is that clear? Whether MI mobile is good or with respect to Xiaomi is good, miss? Both are same only. Both are by same company. Everyone knows that one. Still, which one is good, miss? How you can compare? They both are with respect to. So comparison is different, and here applying the histogram is different. So here we are having the histogram concept is not applicable for the discrete variables. So you should not apply this one. Check for normality. No need to do. Directly load the data set. After that, load the data set, select the test. This is common. Select the test and calculate the p-value. This is common. And based on the p-value, accept or reject. Based on the p-value, either accept or reject the null hypothesis. Either accept or reject the null hypothesis. This is common. Everything is common. Only normality is not there. Only normality is not there. Remaining everything is common. No need to check the normality. Directly you can proceed to the test. Sir, if I am proceeding with the test directly without checking the normality, then what is the difference between parametric and non-parametric within the discrete means? There is no non-parametric test for discrete variables only. For discrete variables, there are no non-parametric, there is no parametric. For discrete variables, only we are having proportion test and chi-square test. There is no parametric, non-parametric is applicable for discrete. That is applicable only for continuous. Okay. There are no separate tests, parametric and non-parametric tests for the discrete variable. So here we are having for this example, null and alternate hypothesis. Null hypothesis says that coach should not be fired. No action. No action to be taken. No difference. Coach is a good coach. Null hypothesis says that coach is a good coach. That since he is a good coach, they have hired him. If he is a bad coach, well, they'll hire first. The company, whoever has hired the coach, whether he is a good coach or a bad coach, means their null hypothesis says that he is a good coach by default. That is the reason they have hired. If he is not a good coach, why they'll hire? Right? Now, so by their assumption is coach is a good coach. Coach should not be fired. Alternate hypothesis means students are saying that he is not a good coach. From company, for example, Naresh IT. Naresh IT assumes that SRK is a good coach. And they have selected me as a trainer. Based on my interview, based on my demo, whatever the things are there, based on that, they have selected their assumption. This is a assumption them. Now, if you don't raise any complaint, they'll feel this one only. If you don't raise a complaint, means there is no evidence for them to prove that I'm a bad coach. If there is no evidence, they'll continue with the same. When SRK is a bad coach, is a bad trainer, and you have to remove him, means you have to prove that. You have to prove this. You have to prove means you have to raise the complaints. If you raise the complaints, then they'll take the action according to that. If there is no data, how they'll understand? They can't decide anything. Nothing. By default is this. This is fixed by default. Okay. Don't make any trial and error on that example. Only for this example we'll do. right? So code should be fired or code should not be fired means just based on the data, right? So third, just we are going to load the data, and after loading the data, we are going to apply the one proportion test. One proportion test is stats dot binom test. One proportion test is nothing but binom test. By miss, only one column will be there. In this column, support or not support. Total 2000 students are there. Total 2000 students. 496 students has written the word called as yes. Remaining 496 students has told yes. Remaining 1504 students told that no, NS means not supported. So for this particular single variable, whether support or not support, for this single variable, if you apply the value counts, on this discrete variable, the output is support is equal to 496, not support is equal to 1504. Only two categories you are having. So it is a binom test, right? So if you are having only one column, one proportion test, for one proportion test, the function name is called as binom test, where you are going to write the 496 and 2000, and you have to check this one, whether for 25% we have to accept or not. Okay, they ask the question with 25%. So for 25%, we are going to do the test. And I got the test answer as 0.85. Directly I will get the p-value only. This particular test will return directly the p-value. If you open this one, it is going to return. In the returns, it is going to return only the p-value of the hypothesis test. Directly it will return the p-value. So whatever the p-value, based on the p-value, since p is greater than alpha, I'm going to accept the null hypothesis. P high, null fly. Okay, you told that less than 25%, but the answer I have got is 24.96, which is almost close to 25. So that is the reason they are not accepting. But if you give the same question with 400, some 406, immediately it is going to be rejected. So now what is the p-value? 7.9. 7.9 into 10 to the power of minus 7. 7.9 into 10 to the power of minus 7, which is equal to 0.000007. Right? Which is less than 0.05. We are going to reject the null hypothesis. In this case, we are going to reject the null hypothesis. Immediately we'll fire the coach. Okay. Is that clear? Since 496 people, almost close to the 25, since it is almost close to the 25, we are accepting. Right? Next example is called as Johnny Talkers. It is not Johnny Walkers. It is Johnny Talkers. Okay. It is a soft drink. Basically, it is a soft drink. Right? Yes. Now you can read this example where we are having the Johnny Talkers sales manager. There is one sales manager and he wants to launch a new intensive program. Intensives. He wants to give intensives. What is meant by incentives? Means if you do good amount of work, additional thing, that is called as intensives. Right? Now, for doing, in order to get this one, means more money than the salary, you want additional, like some kind of tips. Okay. So now if you want more amount than your salary, then what you are going to do? You have to do the more work. More work means more sales you have to do. For the people who are doing the more sales only, they'll get this one. Normal sales they are doing means they'll not get this one. Additional benefit they'll not get. Now, he wants to launch this program where he wants to increase the sales of this one. And now what he has told, I'm going to launch this kind of program where if you get more than this, I'll give you additional intensives. Okay. Now the sales people, what are the sales executives are there? They told that, sir, for this particular soft drink, selling only more. If you give like this targets miss, it is not possible. Right? So they felt that adults won't buy this drink. Adults are not buying this drink. Only the children are buying this drink. Adults are not buying the drink. Only children are buying the drink. Since children are buying the drink and adults are not buying the drink, it is very difficult to sell that much of products. If more number of adults are purchasing, means they'll purchase. If, for example, cool drinks are there. Okay. Cool drinks, adults will drink. At the same time, children also will drink. Now, same Rasna is there. Who will drink generally Rasna? Adults are drinking Rasna. Only children will drink. Okay. Generally, the children will drink. They'll try to drink something Rasna or something, right? Or if you go with some kind of chocolates, that also children's generally. Now for children's, whenever we are having with the children's drink, right? Now, what is the problem with the children's drink means if the children wants to purchase the cool drink means they have to take the money from the parents only. Whereas adults, they want to buy means no need to ask, directly they'll take from their pocket, right? That is the advantage with the adults. But whereas children's means they have to take from money from the parents. Now, here, what the particular sales executives are saying that, sir, please don't launch this program because this program, the reason behind that is children are only liking our drink and others are not liking our drink. Executives has told like this. The manager has shocked. Hey, what is this? What are the soft drinks we are having? Adults are also buying. No, sir. Children are only buying. And he wants to check it that. So here I'm having a data set. This is the data set. In the data set, adults purchased, adults not purchased. Both are there. So within the adults purchase, how many people has purchased, how many not purchased? Within the adults, how many purchased, how many not purchased? Similarly, within the children, how many purchased, how many not purchased? We are having both of them. Now, if both the ratios are same, if ratio of purchasing of adults and the ratio of purchasing, for example, out of 100 people, 30 people are purchasing. Adults are 30 people are purchasing, 70 are not purchasing out of 100. Out of 100, here 32 are purchasing and 60 are not purchasing. Now, what is the ratio of purchase? What is the ratio of purchase of adults? 30 out of 100. 30 out of 100 are purchasing. What is the ratio of children? 32 out of 100. Now, in this case, both are same or different? Almost with respect to same. Now, for example, let us assume in this case, children 32 out of 100 are purchasing, but adults 3 out of 100 are purchasing. Now, in this case, the ratio is different, right? So they want to check whether both the ratios are same or different. The percentage of adults purchasing and the percentage of children purchasing both are same or not. This is the hypothesis test. If both of them are same, means my product will be sold by the adults. My product is getting purchased by the children. Both of them are purchasing. If I clearly understand that children only purchasing and adults are not purchasing, means according to that, we are going to design the program. Now here I'm having adults and children. Let us see with respect to the data set where I'm having the adults are there and also children's are there. Children's, right? So both of them are there. Children's are there, adults are there. Within the children, purchase is there, not purchase is there. Within the adults, purchase is there, not purchase is there. Overall, I'm having both of them. Now what I'm going to do? Just I'm going to take the cross tab. Already we have discussed the cross tab. When we are having two discrete variables, we are going to apply the cross tab. So just I'm taking the cross tab. Now you can see here, total adults. What is the total adults? We are having 480 adults. Total is 480. Out of 480, 58 of them purchased. 58 out of 480. Now, what is the total strength of children? Total is 740. Out of 740, 152. Whether both of them are same? Ratio. Whether both the ratios are same? That you are going to apply the test. The test is called as chi-square test. The test name is called as chi-square test. If you are having only one column, for one column, you have to go with the one proportion. If you are having more than two columns, two or more than two, just you can apply the chi-square test. Exactly two columns are there means two proportion test. You can either go with the two proportion test or chi-square test. For exactly one column, if you are having only one column, go with the one proportion test. If you are having greater than or equal to two discrete columns, then you can apply directly the chi-square test instead of applying the two proportion test in between. Similar to two sample t-test versus ANOVA, same type. Okay. So if you go with the chi-square test and after the chi-square test, you are going to get the p-value. The p-value is 0.0001, which is less than the alpha. Since p low, null go, reject the null hypothesis. Right? Exactly two only is there means you can select two proportion test or chi-square test. If you are having more than two means you have to go chi-square only. There is no other option. For exactly two only, we are having two tests. They have created two different tests for exactly two. For more than two, chi-square directly. Is that clear, guys? So that is with respect to the inferential statistics, right? Different types of tests. So you can please practice. And if you are okay, miss, tomorrow I will conduct the test. If you still wants the time for additional practice, miss, day after tomorrow also I'll conduct. For me, you writing the exam and getting the score is important. Conducting the test is not important for me. There is no rule for me to conduct immediately. It is not like internal exams or external exams. Fixed dates are not there. We can choose as per our choice. When you are ready, then I'll take the test. Right? If you're okay with tomorrow, miss, I'll take the tomorrow. If you're not okay tomorrow, day after tomorrow, miss, I'll take day after tomorrow. Which one? Tomorrow or day after tomorrow? How many of you interested to go with tomorrow? Just twice. One. How many of you are day after tomorrow? Done. As per voting, day after tomorrow. Right? So please, day after tomorrow, take the inference statistic test. It is one of the most important topic for the data analyst role. Right? Yes. So here in the chi-square test, if you see the test in this particular function, if you open the function, in the function, it is going to return total multiple values. Out of the multiple values, the first one is called as test statistic value. The second one is called as p value. So whatever the test output you are going to get, the second value. How to get the second value, miss? By using the index number 1. How to get the first one, miss? By using the index number 0. So by using the index number 1, I'm going to get the output as with respect to the p value. So just by writing the index number 1, exactly I'm calculating the p value. Now, based on the p value, I'm going to conclude. Right? So if you don't want this one, means directly here itself, you can see the p value. Clearly, they have given the p value. Earlier, this is not there. Now they have upgraded. In the earlier version, it is not having the p value separately. You can't see the p value out. Okay. Is that clear, guys? Next. Descriptive. What is the difference between Leavenworth test and t-test independent? Leavenworth test says with respect to whether the variances are equal or not. Variances are equal or not. Hypothesis, whereas two sample t-test is applied on the two different columns. You may check with respect to mu, maybe mean. You may work on the standard deviation. You may work on the variances. You may check between two columns, anything. But in the Leavenworth test, purely it will apply between the variances. It will check only the variances are equal or not. Is that clear? Who is the person who asked the question? Sri Charan, is your question is clear? Leavenworth test works only on the variance. Whereas t-test can be applied with respect to two samples between them, whether the means are same or whether the variances are same, whether the standard deviations are same or not. That is the two sample test. T-test underscore IND is two sample test. Next, Abhishek Bhaskar. Sir, I want to do more questions on this. Any particular websites? One and only website called as Google. Google.com. In the Google.com, just type the questions you'll get. I mean, topic name. Just type the interview questions on one sample, interview questions on two sample, interview questions on ANOVA, interview questions on chi-square. Just type like that. For each test, type the interview questions. You'll get multiple interview questions. Right, guys? So that is the end of the session. Thank you. And we'll meet tomorrow. Bye, guys.